Welcome to this tutorial on advanced control structures in Python. In addition to the basic control structures, Python has some advanced control structures that can be used to control the flow of execution of a program. The first one that you are going to look at is the try and except statements. The try and except statements in Python allows us to handle exceptions, which are errors that occur during the execution of our programs. Some of the exceptions may include the first one is zero division error, and this one will only occur if you try to divide a number by 0. You can go ahead and have an example. For example, if you wanted to declare a variable called x and the value is 1 divided by 0. If you try to execute that, you get an error. The error that you get is a zero division error. The next error we can have a look at is the type error. And this error occurs if you try to perform an operation on incompatible types. And for example, you might decide to create another variable called x, and you take a string, add 5. We know that that's not possible to add a string to an integer. So if you try to run that, we get type error and says can only concatenate string, not integer, to string. The next error we can have a look at is the name error, and this exception will only occur if you try to use a variable that has not been defined. For example, so far we have not declared a variable called y. So let's see if you try to print that variable called y. You get name error, which says name y is not defined. Another exception is called the index error, and we can have an example. Suppose we have a list maybe called my list, and it has maybe the elements 1, 2, 3. And as you can remember, we always start counting from index 0. So which means this is index 0, this is 1, and this is 2. Suppose now you wanted to get index 3. What happens? We don't have the index 3, but you want to call it anyway. So what you get is an error message, and the name of that error is index error, and says list index out of range, because you're trying to get index a list that only gets to index 2. So that's when you get that error. The next error you get here, you can get from Python program. It's the one called KeyError. This is associated to dictionaries, and for dictionaries, suppose you have a dictionary called myDict. It has a key called A and B, and they have the values 1 and 2 respectively. Suppose now you want to get some values for a certain key. And then suppose now you want to get the key, the value for a key called C. If you try to execute this, you get a key error because we do not have a key called C in that dictionary. And the next thing that you can, and the next exception that you can get is called the value error. And suppose you wanted to convert string to integer. Let's see, let's just try this and see. You get value error because you're trying to convert string to integer, which is not possible. That's why you get the error called value error, and it says invalid literal for integer with a base of 10. So foo is not an integer and can never be converted to integer. So, and that's basically a few examples of exceptions. Now the biggest question is, how do you handle these exceptions? And to handle the exceptions, that's when try and except statements come in. So for example, if we wanted to handle specific exception that might occur in your program, we use the try block. Suppose you have that and you have 0, maybe something like you have a number that's being divided by 0. You're trying to declare a variable which takes the value of 1 divided by 0. So we know that we'll get division by 0 error. So what we do, we need to handle that exception, and we have to declare another block called except ZeroDivisionError because we know we are going to get that error. And in that block, that's where you write the error message that you want to display. And in this case, we want to print out error message saying error division by 0 is not allowed. And so from these two blocks, the try and except block, we see that the try, that's where the code goes, the one that you feel like that can generate an error. And in the except, that's where we print out the error message. So we can try to execute this, see what we get. We get the error division by 0 is not allowed. In some instances, we might want to handle multiple exceptions. And to do that, there are two ways to do it. So the first way is by using the following piece of code. Here, in the try block, you might have two sets of code that might generate different exceptions. In our case here, we are trying to convert a string to integer, which means we are going to get an error, the value error, and also we are trying to divide by 0. So because we want to handle both of these errors, then we use in the except block, we use a tuple and include both errors in there and print out an error message saying errors, an exception has occurred. So for example, if I try to execute this, automatically I get error, an exception has occurred. The other way you can handle these exceptions, different exceptions, we can use two separate except blocks. And in our example here, we are trying to convert an integer is a string, but with a digit 5 or integer 5 enclosed in that string. So this one is possible. We can convert a string as long as it's a digit enclosed in the quotes. We can convert it to integer. So this one is not going to generate an error. So if I try to execute this, given that I have to accept blocks, one meant to handle the value error and another one supposed to handle division by 0 error, we are going to get, if I execute that, I get error division by 0 is not allowed, which means this error didn't occur. So we only handle the second part. Suppose now we had something like our original foo string. If I try to execute this, note what happens. I get the first error message, which means because we had two error message happening, two type of errors happening, only the first one was handled and the second one was not handled. So suppose we only had one error, which is the value error. Suppose we had this to be, let's say we had this to be 3, which means we are not going to return the division by 0 error and execute. We still get the first error. Suppose now we had this to be 5 and this to be 0. Let's see what happens. If I execute this, I get error division by 0 is not allowed, which means given that the first error didn't happen, this was ignored, but the second error was handled here in the second except block. So as you have realized, if you have both errors happening, only one error will be handled using this piece of code here. So to be sure that you're handling both, then we use this except block. We use the except block with both errors represented in the tuple, but you cannot have a specific error message for them. You only have a general error message. So if this happens, then you have to go back to your code and see which specific error happened. So, which means this can now handle both errors, but this is only able to handle one. And this is very important since suppose you wanted to have someone input some values. Maybe this was a value and this was a value that has to be input, and we are not sure at the point of designing the code if someone will actually type something that might generate an error. That's why we can have these two, but this will not work if two errors occur. And as I mentioned earlier, we have different type of errors. So to handle any of them, we use this. We have to specify whatever you want to check in the except block. Now suppose none of the errors occur. It means that you want your code to do something. If there's no errors and you don't have to handle any errors, then it means that you need something to be done after that. And that's where we can add two kind of blocks. There's one block called else block that will go with try, except, and then you can add, after except block, we can add else block. And I'll explain that using an example. Suppose you wanted to convert an integer to a string to integer, and there's no error. Or for example, I can choose to write full. If I execute this, I get an error, which means that I have to handle. But what if now this was 5 and the string 5 was actually converted to integer, meaning that there's no error to handle. That means that you need to do something else, which is we are supposed to use else block. And what else does, you can specify a block of code that should be executed if none of the errors occur. So in this case, if I execute this, you'll see that the input value is valid, which means the else block was executed. I hope that is clear. Now, suppose that you wanted to specify a block of code that should always be executed regardless of whether an exception occurs or not. Here, we use the finally block. I'll use an example to demonstrate that. And we can use the following code. So what this piece of code will do, suppose you have an error that we expect to happen or to occur, and is a zero division error, and it's being handled in this except block. And even if the error occurs or not, we still want to print out or to execute this piece of code. Finally will allow us to do that. For example, if I execute this, and note that there's an error that will occur. If I execute that, I get this printed out. Error division by 0 is not allowed, and this is also printed out. This code will always be executed regardless of whether an exception occurs or not. So that's in the situation where the error had occurred. But in the case where maybe assuming that the error didn't occur, we can change the 0 to 3, meaning that this operation is allowed. If I execute that, I only get the finally block being executed, which means it's prints out this error message, which is this code will always be executed. So as you have seen, a finally block will be executed regardless. And I hope that is clear. The finally block is useful for cleaning up resources or performing other tasks that should always be done regardless of whether an exception occurs or not. For example, you might use the finally block to close a file or a network connection that was opened in the try block. For example, assuming here you're opening a file saved in maybe a certain directory in your computer, and you expected that an error might occur. Maybe you wanted to open it and do some operations or write some materials, write something in the file, only to realize maybe there's an error. If an error happened, you still want to close that file. So that's where finally block comes in, because either way, whether the error occurred or you're trying to write the file, you still want to close it. So we use the finally block. Hopefully that is clear. The next thing we are going to look at is the break and continue statement, and have it as a heading. So the break and continue statements can be used to control the flow of a loop in your Python program. And the break statement is used to exit a loop prematurely, while the continue statement is used to skip the rest of the current iteration and move on to the next iteration. I can use an example. I can have a code here. I can add a cell. Suppose now you want to use break to exit the for loop. What this will do, the output for this would be, for this code, would be the numbers 0 to 4. Since the break statement will cause the loop to exit when the value of I is equal to 5. And we can actually execute that to see. So it prints out the value of I is equals to 1, 2, 3, 4, 0, 1, 2, 3, 4. But when it gets to 5, when the value of x is equals to 5, or the value of I is equals to 5, then it breaks the loop, and that's it. Another example of how to use continue, we can also use an example. And for this example, what you're trying to do is print out even numbers from 0 to 9. So what this code will do, it will print out even numbers 0 through 8, since the continue statement causes the loop to skip the rest of the iterations when I is odd. And if you can remember, this operation, this is the modulo, and what it does, it just checks if there's a remainder when a number is divided by 2. And as we know that odd numbers are not divisible by 2. And it means that they will always leave a remainder of 1. So this condition is just checking if the number is odd or not. So if it happens that the number is odd, then continue will skip to the next iteration. Now when the value of I becomes even, meaning that this will be violated, then the value of I will be printed out. So that's it for the break and continue. The next thing we are going to look at is the pass statement. For pass statement is just used as a placeholder when a statement is required but no action needs to be taken. For example, you might use a pass statement as a placeholder in a loop that has not yet been implemented. For example, suppose you wanted to do something with a range from 0 to 9. The reasons why I'm saying 0 to 9 is that this is 0 to 10, but in that range, this is not included. 10 is not included, meaning that since it starts from 0, for 10 items, the numbers that we want is 10, but starts from 0, so it's 0 to 9. And you just write this pass will act as just a placeholder for a future code. You can now decide to come and write something like this, a piece of code here. So this is just acting as a placeholder. This will be executed, but there's some sort of operation that is required, but no action is required at this moment. So this can be left there to act as a placeholder. And so you can say being used as a placeholder in a for loop. Also, this can also be used in a try except block. For example, you might have something like this: a try where a number is being divided by 0. We expect an error. But at this point, when you are writing this piece of code, we are not sure what we want to add here. So you want it to occur, but you're not sure what you want to have at the moment. You know there's an error, but you're not sure what you want the code to do. So you just leave the keyword pass to act as a placeholder for future exception handling code. So I hope that is clear for pass. So basically, we say that the pass statement is often used as a placeholder when developing code, and is later replaced with actual code as needed. And that's it for this tutorial on advanced control structures. Just a recap, in this tutorial, we covered some advanced control structures in Python, including try and except statement for handling exceptions, break and continue statement for controlling the flow of a loop, and the pass statement, which act as a placeholder. These control structures, as you've seen, can be very useful in Python programming and can help you write more robust and efficient code. And what I would urge you to do is please try and practice using these control structures in your Python programs to get a better understanding of how they work, and that will be super helpful for you. Anyway, thank you for watching, and please do remember to subscribe, comment, and like my videos.